Here's a question in Math AS that I wanted to make a video on. It says my friend has $560 to spend on a fence for her rectangular garden, so I drew a rectangle. She wants to use cedar fencing on one side, and we don't know how much that is, so I just let that be X yards. It costs $18 a yard. And then the rest of the three sides, they want to use cheaper metal fencing, so I labeled that metal, metal, metal. And it costs $10 per yard because it's cheaper to make the metal fence. So I let this dimension be X yards, and I let the longer dimension be Y yards. The question is, what are the dimensions of the garden with the largest area that she can enclose given that she only has $560? So this is a classic example where you'll come up with two equations and you'll have to make a substitution. So this basically outlines how I approach the problem. If you wanted to write a cost function, C, shown here, you'd have to figure out how much it costs to build all four sides of the fence. So let's take the cedar side, for example, which costs $18 per yard. So it costs $18 per yard times the number of yards, which is X, and that would give you the cost of making the cedar fence. So that would be 18X. Add to that the X yards of metal, which costs $10 per yard. So if it's $10 per yard times X yards again, because this dimension is the same length as that dimension, it'd be $10 a yard times X yards to make this side, so that's 10X. And then these two sides would be made out of metal, which is $10 per yard times Y yards, but there's two of them, so one side here would be $10 per yard times Y yards of fence, and then down here you'd have $10 a yard times Y yards of fence. If you combine the X's and the Y's, the like terms, you get this. Substitute the cost in. She can afford a cost of $560. The problem is that we're supposed to find the dimensions, that means X and Y, of the garden with the largest area. If we're going to find the largest area, we need to first write down a formula for the area of the garden. So we want to maximize the area, where the area formula would be found by finding the area of a rectangle, which is always just the length times the width. So my dimensions are X and Y, so the area of that rectangle would be X times Y. So here's a classic problem that I've got a function of two variables, and if this is college algebra, you'd be able to, if it was one variable, you'd be able to type the equation your y equals, use your max feature. If you're watching this video in my calculus class, then I'm hoping that you don't do what I'm about to do in this video, and you actually take the derivative, set it equal to 0, and approach it that way. But nonetheless, you've got this formula that I could type it into my calculator, but the problem is it's a function of two variables. So basically I have two equations, I've got two variables here, and this is a classic example where you want to make a substitution. So what I did is I took my cost function right here, wrote it down, and you have to decide either to solve this for X or for Y. So I just arbitrarily chose to solve it for Y. It would work either way, but I chose to solve for Y. So if you look over here, all I did was subtract the 28X over, so you'd have 560 subtract 28X, and then once you did that, you'd have to divide the 20 over, and this was the equation you'd get when you solve for Y. So this is my cost equation, solved for Y. I've got this other equation that I'm trying to maximize, area is X times Y. Now remember I said we can't really put this in our calculator because there's too many letters. So the reason I solved this for Y is so that I can make a substitution. I can take the letter Y in the second equation and replace it with this business over here. So if you did that, it would be area is equal to X times Y, where Y is this ratio here. So if I was to make that substitution, we would have the area formula entirely in terms of X, which is perfect. I can type this into my Y1, I can graph it, I can use my max feature, and to wrap my mind around it, my input would be X, which would represent the number of yards of cedar I'd have to use, and that would go in for this blank right here, the length for the cedar side. And then the output, now my calculator is going to call it Y, but remember the output would be the area. So when I use my max feature, it's going to tell me both X and A. It's going to tell me the maximum area, and it's going to tell me what X should be, that length, how much cedar we should use to build the fence. So here goes. If you're in my college algebra class, you'd be going to Y equals and typing this equation in like X, parenthesis, what is it, 560, subtract 28X, and then all of that's being divided by 20. Now I'm just going to go to my window, which is a standard right here, And this really wouldn't make any sense because my x is the length of this side, and we know that you can't have negative 10 yards. In fact, the smallest that you could build the thing, and you really can't even do that, would be 0. So if you want to put your x min at 0, that would be the smallest that you could make the fence, is just to not make it at all. And how big it needs to be, I'm not sure. It's probably going to be much more than 10, but let's suppose I just leave that alone for a minute. Now my y min and my y max, remember my output is really area. So since I haven't even done a numerical example, I don't even know what it's supposed to come out to be. So I'm just going to hit graph, and things aren't going to look good. This is a quadratic with a negative coefficient if you were to multiply it out, so we're going to have an upside down parabola. So I need to fish around and see what a good window would be to find this maximum. So my favorite way to do this is to hit trace, just so that I can see some inputs and outputs. So for example, this says that if we made the cedar side 5 yards, we would get an area of 105 square yards. But that's not necessarily the maximum area. So if I trace to the right, I'm looking for the biggest y value, the biggest area that comes out of this. In fact, I'm just going to hold the right arrow down and just see how big my y values get, remembering that my y values are the area of the, I think it maxed out right there. So if somewhere around an area of 140, it looked like it maxed out. And to get that maximum area of 140, it looks like I need to use 10 yards of cedar fence. But if you want to see the picture here, what was happening as I was tracing to the right was the calculator was automatically changing my window. So we had this from 0 to 10, and my calculator changed it from 1 to 11. So now that I know the answer is basically 10, if you wanted to see the picture, you could put your x min at 0, you could put your x max bigger than what you think needs to be. I'm thinking the answer is 10, but whatever the answer comes out to be, you could go bigger. Like for example, I might go 20. And then the maximum area was something, I think I have a bad short-term memory. What was it, 140 or something? So maybe you'd go a little bigger and maybe even say 300, just so that I can guarantee that I see the graph of this. So if I'm patient, I'll see the graph of my area versus how long I make that cedar side. So now, if I was to trace up there, you could get, well, this is a fluke that it starts out on the exact maximum. But in general, you're not going to get right on the maximum. You're going to have to use your max feature. So for this particular problem, I got lucky and numbers are coming out nice. But in general, you're going to want to go to your calc menu here, which is second trace. And you're going to want to use your max feature, which is number 4. And it's going to ask me to pick a point to the left of the max and to the right. So I'm going to trace to the left here. You could type in your left bound, like I could just type in 0, because x equals 0 would correspond to a point to the left, or you can trace to the left a little bit and just hit enter. Now the calculator knows that the maximum happens to the right of this line. Then it wants a right bound. Well, you could just type in like 15 or 20 if you remember what the window is. This is 20 over here. So you could type in 15 or something, or you can trace. Just depends on how you want to do it. If you trace over there, a good right bound would be some point way to the right of the maximum. And then you hit enter. And then now the calculator knows to look in this interval here that you've given it between these two vertical lines. And the guess really isn't that important here. I usually just press enter, but it wants you to guess by going back over. The downside about that is because you're close to the maximum, students think this is the answer, which it's not. It's just your guess. You need to press enter that third time. And it says the maximum is not 10. Remember that x represents the number of yards of cedar. My output is not really y. It really is, if you remember right, we replaced y where there was an a in my equation down here. So the output there actually isn't the number of yards of metal. It actually is the area in square yards of my rectangular garden. So the maximum area is going to be 140 square yards. And we build it by making a cedar side 10 yards. So I know 2 answers. Length of the cedar side, 10 yards. The maximum area is going to be 140 square yards, but it also wants to know how to build it, so we have to figure out how many yards of metal we need on this side. So we're going to use 10 yards of cedar on this side. We're going to use 10 yards of metal here, but how many yards of metal do we do on the long side? Probably the easiest way to do that, since we know x is 10, maybe the easiest way to find y is this equation right here. This is an equation that we already bothered to solve for y. So if I replace x equals 10 in this equation, I could find out the y value. So I'm going to just do that sort of in my mind, but really in my calculator here. I'm going to hit second quit, and I'm going to type this out where I replace x with 10. So that would be 560, subtract. Now if I replace x with 10, that would be 28 times 10 is 280. So my numerator comes out to be, if I press enter, 280. And I divide that by 20, and I basically get a y value of 14. So even though, well, I guess my picture's not, well, I guess it's kind of to scale, but if x is 10, it turns out y, the number of yards of metal on this side you need to use, is 14. So my picture isn't really to scale. I mean, if this is 10, how can this long side here be 14? But I didn't know what the answer is going to come out to be ahead of time. So hopefully if we submit this, we get green all the way across. Part 1 we got green, part 2 we got green. So this is an interesting question you can do in college algebra with the graphing calculator, or if you're in my calculus class, we would take the derivative of this, which would be just a linear equation, set it equal to 0. And why that would make sense is if you're trying to find the maximum here, you'd have a horizontal tangent line, and the slope of that tangent line would be 0 there. So if I took the derivative of this, it would be a linear, and I'd want to know where the slope is 0, so I would be setting equal to 0 and solving, and you would get your x equals 10 that way. So hopefully this was helpful.